Hello and welcome to the Brain and Psychology. In this lesson we're going to talk about the limbic system, the reticular activating system, and the cerebellum. We'll start with the limbic system. There are four structures I'd like you to know about the limbic system. Those are the thalamus, hypothalamus, amygdala, and hippocampus. The function of those four structures in the limbic system in general is to help us learn, to control our emotions, our fears, and to help us store memories. The thalamus is just underneath the corpus callosum at the top of the brainstem. It really is a relay station, or as some people think, a triage nurse, because impulses are coming in and it has to decide if it's important enough to send up to the higher parts of the brain. So it integrates our sensory and our motor information, and it relays that sensory information up to the cortex, so the cortex can respond to it appropriately. The amygdala is an almond-shaped structure. There's two of them on either side of the brain, at the base of the brain, and the amygdala is best known for our fear response. It's also important in the control of other emotions and in recognizing facial features that might show emotion for other people. There's a case of a middle-aged woman that has been called SM, and she has severe damage to her amygdala. Because of that destroyed amygdala, the normal fear response is not present in this person. So she has no fear of snakes. When she goes to a horror movie, she laughs. And when she goes to a haunted house, she has no response. So totally blunted fear response that most people would normally have. A study has looked at the differences between heterosexuals and homosexuals in their amygdala activity. If you look to the far left, you see a heterosexual man, and the amygdala response in verbal and psychological tasks that are not related to sexual activity, you will notice that he has most of his amygdala activity in his right amygdala. We can compare that to a heterosexual woman, a homosexual man, and a homosexual woman, and you'll notice that the amygdala activity for a heterosexual male is most similar to a homosexual woman. If you look at a heterosexual woman, you'll notice that the majority of her activity in the amygdala will be on the left side, with some on both. So she really has a much more in-tune emotional response to other tasks related to verbal and psychological tasks, mainly facial features, those kind of things. Again, if you compare the response of a heterosexual woman's amygdala activity, it very much mirrors that of a homosexual male. The next structure is the hypothalamus. The hypothalamus is really a nervous system and endocrine system structure. So it really is the link between the nervous and endocrine system. It also secretes important hormones. The hypothalamus is important in our thermal regulation, or regulation of how hot we are, and whether we sweat, whether we shiver, those kind of things. The hypothalamus is important in our sensation of hunger and our desire to eat or know that we're full and stop eating. And a fourth thing it does is it regulates our sexual activity. I remember this by saying the hypothalamus is responsible for the 4 H's. It makes us hot, horny, hungry, and it regulates our hormones. The hippocampus is a structure that resembles a seahorse. That's where the hippocampus name comes from, and it's vital for our memory storage. If somebody has a damaged hippocampus, they will not be able to remember and store their memories. Some interesting associations with damaged or decreased hippocampus is its effect on sleep. There's been a correlation between a decrease in the size of our hippocampus and people who suffer from insomnia, which is lack of sleep, of course, and then also the disease of narcolepsy. Narcolepsy is just the opposite. People fall asleep at random times and maybe even go a little catatonic during those periods of time. So a damaged hippocampus or a decreased hippocampus can be correlated to both of those sleep disorders. Let's stop for a brain scan. Match the part of the limbic system to its major function. There are thalamus, hypothalamus, hippocampus, and amygdala. The main function of the thalamus is to relay sensory information to higher brain centers. The main function of the hypothalamus would be sex drive. A main function of the hippocampus, memory storage, and a major function of the amygdala is our fear response. Another fascinating structure is a reticular formation or a reticular activating system. This is not one structure, but a series of nerves that run from our brainstem all the way up into our higher brain functions, up into our cerebellum. And it's just a loose organization of webbing of nervous material, but its main function is to help us respond appropriately to stimuli when we aren't necessarily paying attention to it. For instance, an example, if you move next to a railroad and a train goes by, initially you will automatically jump when the train goes by and you'll notice it. When you're sleeping and the train goes by, you'll wake up because of the loud noise. Your reticular activating system will eventually habituate to that. And so you can sleep through the night, the train will go by, the reticular activating system will notice it and think, oh, it's not important, and it won't wake you up. It won't send that impulse up to your brain. By the same token, if you're a parent and you have an infant and you're sleeping and you notice the slightest whimper of your infant, your reticular activating system will wake you up immediately and think, oh, something, this is important, I need to attend to it. So it helps us in habituation for things we don't need to pay attention to. In fact, it's happening to you right now. The clothes you're wearing, you don't pay attention to the fact that you can feel your clothes. If you did, it would drive you crazy. So those kind of things, it's like, okay, we get used to it, we stop paying attention to it. It also helps us either go to sleep or remain conscious. Some people who have disease of the reticular activating system might actually go into a coma because they will not wake up. The last structure of the brain we're going to talk about is the cerebellum. The cerebellum is at the very base of the brain, behind the brainstem and underneath the occipital lobe. And the cerebellum is responsible for our coordination. Our muscle movement occurs from the frontal lobe. So that primary motor cortex we talked about, is in purple here, will initiate a muscle movement. But that muscle movement will be very jerky. So the muscle movement first goes through the cerebellum, and the cerebellum coordinates that movement to make us walk smoothly, be able to have our hand movements smooth. All our movements will be smoothed out and balanced through our cerebellum. It also helps control our balance. I want to show you a video for somebody who has a problem with their cerebellum, and you'll see how their gait is so different because they have such a hard time walking.
So I'll just take my hand here, and we'll just make it across this here.
So in this patient with cerebellar damage, she has what's called an ataxic gait.
Balance.
So it's a wide-based,
That's
irregular
fine.
gait.
Let's go back.
The frontal lobe initiates the activity, but her cerebellum is no longer able to smooth out that activity. The same thing can happen with her arms.
Just put the pen on, the cap on the pen. Okay, good. And now I'm going to hold the cap out here. You can put the pen on. Okay. And the other side, same thing. And put the cap on the pen. Good. And now just go from the tip of your nose, the tip of the pen, back and forth. And I'm going to move the pen. Okay. Good. Another hand.
So in cerebellar damage, you notice how shaky the person's movements are.